English Longitudinal Study of Aging, ELSA. ELSA User Webinar, the 3rd of December 2025.
Good morning, everyone. My name is Giorgio Di Gessa, and I'm going to be leading the data user session. We're going to have 3 different presentations. The first one is on types of data available and how to access them. Then there's going to be a presentation on weighting in ELSA, and finally, a presentation on derived variables. Just a reminder again that you're more than welcome to ask us questions through the Q&A function. You can ask them anonymously and give them the thumbs up so that we can answer to all of them, and we will answer either throughout the presentations or at the end of them. And also a reminder that all of these presentations are going to be then available in the next few days through the ELSA website and our YouTube channel. Finally, a reminder before I give the floor to Lynn and Domenico that if you have any questions, you can always contact us as well through our email address, that is elsa@ucl.ac.uk. And if you are very specific in your questions, we will try to get back to you as soon as possible with detailed answers. So without further ado, I'll just give the floor to Lina and Domenico and ask them to present on types of data that we have and also how to access them.
Okay, thank you very much, Giorgio. I'll just share my screen now. I am going to be presenting in collaboration with a colleague from UKDS. So I'll just give you a quick overview first of what specific ELSA data sets we have available on UKDS, and then Domenico is going to take you through the different levels of data security we have on UKDS and kind of what actions you need to take in order to gain access to the data. So we have quite a lot of data sets. We have 32 different types of ELSA data sets archived in UKDS. They're classified under something called SN in UKDS. And within each of these types of data sets, we have multiple waves, multiple versions of the data set as well. So these are just kind of the headline types of data sets we have available. So you've heard about quite a few of these ELSA sub-studies today. But we have our main data depository is SN 5050, which houses our main ELSA interview and the end of life and the health visit data sets for all the waves up to the latest wave. And the ELSA data is available at end user license, secure license, and secure access on UKDS. Then we have the COVID-19 sub-study, 2 waves. So this was a sub-study that was run throughout COVID when the field work for the main ELSA had to stop. Then we have the life history. We currently just have 1 wave, and that was conducted at wave 3. But we are just depositing the second wave, which was conducted last year as we speak. Now, so that will be available very shortly. And then the HCAP sub-study, we have 2 waves of that available in UKDS under both EUL and secure license. We also have ELSA polygenic scores and variety of geographical data sets, which include urban, rural indicators, index of multiple deprivations, MSOAs, LSOAs, local authority districts, population density, but these are available only at secure license and secure access. So yes, if you go on to UKDS, you can search by using the keywords ELSA, end of life, and so on, and you'll be able to find all these data sets. UKDS is one of our major data depositories where we deposit all the latest ELSA data. So now I will pass you on to Domenico to tell you more about different licenses in UKDS and how to gain access to data sets.
Hello, good morning. I come from the UKDS to explain some of the types of data available and how to access them. Lovely. I'll start explaining like the types of data available or the types of access that we have. Each dataset held in the UK Data Service collection has a designated access level. This depends on factors such as sensitivity, risk of identification, and granularity of the data. The access level indicates what are the steps needed to gain access to the dataset. Each dataset has this purple box, as you can see now in the screen. This is our catalog page. This is the access study data, in which you can see the list of requirements to be eligible for access. For example, this is the main ELSA study, and the most accessible one, or the more accessible version of it, which is SN5050. And to access it, you need to first be registered with the UK Data Service, and with the registration comes a signature of the end user license agreement. You need to ask for a data owner to use the data if you're a commercial user. You have to agree not to attempt to link the data with the Health Survey for England datasets, or to try to identify participants or geographies from ELSA using the Health Survey for England data. The first type of data, or the first type of access that there is safeguarded access. These are legally not personal data, as they are effectively anonymized, and the risk of identification is sufficiently remote. Use of this data is subject to the end user license agreement, as every dataset really in our collection. These data are made available for registered users, and in some cases, subject to additional conditions and agreement that have been put in place. These data are available to download in 3 standard forms, which are Stata, SPSS, and TAB. Our next type of dataset or access, well, can you see the screen? Oh, there you go. Our next type of data access is safeguarded special license data, which is a more restricted version of the safeguarded access. The data has been anonymized, but contains more detailed information, so there's a higher risk for identification compared to just safeguarded data. The use of this data is subject to the end user license agreement and the special user license agreement. Researchers wishing to access this data must complete an application which needs to be approved by the data depositor. The process goes as follows. The researcher submits the application to our help desk. We will screen the application and send it to the data owner. They might ask for amendments, which may require back and forth. So please ensure that you submit your applications with plenty of time before the project is due to start. In this application, it's important that you justify why you need to access the specific datasets rather than a less restrictive version of it. Mentioning specific variables will help for clarity to the data owner. For this type of data too, we have additional data storage and handling requirements, which can be found in the guide linked. Users must follow these requirements in order to be given access. It's also important to remember that after working to the data, after the authorized period lapses, users must ensure that the dataset has been deleted as per the guidance provided. Users must confirm this in writing. Not doing so consists in a license non-compliance and will restrict you from applying for more data in the future. There's also a restriction in geographical datasets due to the increased risk in identification. For example, ELSA special license geographical datasets have a maximum limit of 3 per project, and some geographical datasets cannot be requested together. You will find this information when applying to the data. Our last type of data is secure access, also known as control access. This data is classified as personal information or personal data and are very sensitive for academic use and not permitted for commercial use. The use of this data is subject to the end user license, the secure access user agreement, and is facilitated by the 5 safes framework. A lengthy project application is required for this one. So again, it's important to have time or request it with time. These data are made available to registered users and trained and accredited researchers whose projects have been approved by the data owner. It is important to remember that access to this data is conditioned if the project has a benefit for a public good. And lastly, this data is too confidential or sensitive to be released via download. So it is only available through our trusted research environment provided by us called SecureLab. I'll be passing it to Lina now.
Thank you. So this last slide is just tips for submitting the special license and secure access applications. So when they come through, it goes through a process where UKDS first reviews them and then passes on to the NATS and UCL, and we review these applications together. And we meet on a fortnightly basis to discuss some of the applications where we have questions. So I just wanted to share some tips with you of things that we often come across the applications, and these are the things why we reject or ask for amendments. So please only request data sets that you need for your analysis. Don't just request, everything and anything. You have to be very specific about why you need the data set and state clear research reasons why you're requesting the data set that you're requesting. Do not request more than 3 geographical data sets. So the application will be automatically rejected because of the increased disclosure risk when combining these data sets. Make sure you fill out your application fully and thoroughly, stating how you are planning to link the requested data sets if you're requesting multiple data sets. Allow plenty of time for your application to be considered before you start your project. So as I said, sometimes we need to discuss various applications, so we meet and we make a decision and then we have to get back, and this process sometimes takes time. Please ensure that you adhere to data deletion deadlines when the application period ends. So you will get data deletion reminders from UKDS when your application is about to end. And if you do need more time for genuine reasons, for example, your project overran or you need more time for analysis, please request for an extension. And most likely we do grant the extensions for genuine reasons. But when your period of data access ends, we do ask you that you securely delete the data. And that's everything from me now. So I will pass you on to Sean next, who will talk about the weighting strategies.
We're still in the morning. Good morning, everybody. My name is Sean Scholes. I am a Principal Research Fellow with the ELSA team here at UCL. and my talk is on weighting. So in terms of content, I will just provide a brief background and try to describe why using weights are important for your analysis. I will try to briefly, in a non-technical way, describe the weights that we provide with the ELSA datasets for conducting longitudinal or cross-sectional analysis. I will provide a couple of examples of using these weights in previous ELSA reporting. And my final slide will give some resources for further information if you are interested. So why is using weights important? Well, basically, weights are designed to ensure representativeness. So using weights is intended to ensure that your samples represent the population throughout the study. So, for example, weights can do this by accounting for complex sample designs. Studies such as ELSA may oversample certain groups to boost sample sizes for your analysis, and so weights are necessary to account for that oversampling. Weights can also adjust for non-response bias. So some groups may be more likely than others to drop out of the longitudinal study over time, or some groups may be more likely than others to choose not to participate in all the stages of data collection at a particular wave. And we know from experience that response to surveys is most definitely not random. So briefly, unweighted data could be unrepresentative data, and so unweighted analyses can lead to biased conclusions affecting both descriptive results as well as estimates from regression models. So this is a complex slide, but I tried to give some idea of what is going on behind the scenes when we are calculating the weights at a particular wave of ELSA. So first of all, there is a selection component. In the selection component, we adjust for unequal selection probabilities. Selection weights equal the inverse of the selection probability, and we achieve representativeness by giving higher weights to those with lower chances of being selected for the study. And in the ELSA study, this has now become extremely important with the creation of the cross-sectional weights at waves 10 and 11 due to the oversampling of minority ethnic groups in cohorts 10 and 11. And as Darmy mentioned, this process will continue going forward in waves 12 and 13. So in addition to selection, there is also an obvious non-response component where we aim to reduce the bias resulting from differential non-response. In contrast to selection probabilities, which are known, response probabilities at a particular wave are not known and so are modeled. Non-response weights equal the inverse of the estimated response probability, giving higher weights to those with a lower probability of responding. And obviously the non-response component is used in both the creation of the longitudinal and the cross-sectional weights. And finally, in terms of calibration, even after adjusting for selection and non-response, the weighted sample may still differ from the population on key variables. And we can use calibration methods to ensure that the weighted sample aligns with the population on those key variables. And calibration methods are used in the construction of the main interview cross-sectional weight. So having given some background, I would now like to discuss the weights that we provide in the ELSA datasets, beginning with the longitudinal weights. So longitudinal weights are provided to enable users to analyze change over time by following the same individuals over several waves. The aim in constructing the weights is to minimize bias due to differential non-response from one wave to the next wave. It's important to note that longitudinal weights are assigned only to core members and are assigned only to core members who have taken part at each wave up to the current wave. So it's a monotone pattern of response. So for example, the longitudinal weights that we provide with the Wave 11 dataset, these build upon the longitudinal weights that were created at Wave 10. The predictors of response at Wave 11 include the usual variables such as demographics, socioeconomic status, and health, and these are variables that we've collected at Wave 10. So we're using information collected at Wave 10 to model response at Wave 11. And non-respondents at a particular wave are mainly non-contacts and refusals. And in terms of variable names in the dataset, here I just give you the variable names for the only longitudinal weight that we provide in the datasets from waves 1 to 7. So these are longitudinal weights created for cohort 1 core members, those who took part in the first wave of ELSA. But from wave 8 onwards, we provided an alternative longitudinal weight, which follows up core members who have taken part in every wave from wave 4. So the longitudinal weight with wave 4 as its base has more core members than the longitudinal weight which has the cohort 1 members at its base. So for example, this slide shows the number of core members at each wave of ELSA who had a positive wave 1 longitudinal weight. So for example, at the beginning of ELSA, we can see that just over 11,000 core members took part in the study and had a positive weight. At the second wave, just under 9,000 core members had taken part in both waves 1 and 2 and had a positive value of the wave 2 weight. Going to the bottom of the slide and looking at the latest wave, we can see that by the time of wave 11, roughly just around 13% of the original cohort members at wave 1 have taken part in every wave since wave 1. So these have a positive value of the wave 11 longitudinal weight, which has wave 1 at its base. And obviously, as these core members have been in ELSA from the beginning and have taken part in every wave, you would expect this to be a very kind of distinctive group in terms of health and wealth, for example. This is a similar slide, but showing the longitudinal weight, which has wave 4 at its base. So at the time of wave 8, when this weight was first archived with the data, just over 5,500 core members had taken part at each wave between waves 4 and 8. But by the time of wave 11, the longitudinal weight with wave 4 at its base has a positive value at wave 11 for just around 2,600 core members. So we apply longitudinal weights to those core members who have participated in each wave to represent the target population across those waves. And the common query is which weight to use. So for example, if you are looking at change between waves 4 to 9, then use the most recent weight, which would be archived with the wave 9 data, and apply that weight to all the core members who have taken part between waves 4 to 9. If you are looking at change between waves 4 to 11, again use the most recent weight applied to the core members who have taken part in each wave from wave 4 to wave 11. We hope that these longitudinal weights give representative estimates. We do a lot of modelling, accounting for non-response bias, but they will not use all the available information because, as we see, weights are only provided for core members who have taken part at each wave. So, for example, a core member who has taken part at each wave between waves 1 to 9, but who missed wave 10 and who returned to the study at wave 11, these will not have a longitudinal weight. It will be missing in the dataset. Cross-sectional weights aim to make the sample representative of those aged 50 and over living in private households in England at the time of each wave. So cross-sectional weights are positive for all the eligible core members who responded at that wave. Core members living in institutions or living in private households in Scotland or Wales are assigned cross-sectional weights of 0. The aim of the cross-sectional weighting is obviously to minimize bias due to differential non-response, to correct for differences in selection probabilities, to align the weighted sample with key population variables, and also importantly to account for the addition of the refreshment sample at the younger ages. We provide different cross-sectional weights at each wave of ELSA. At wave 11, we provide the main interview cross-sectional weight. This is created for all core members who have taken part at wave 11, who are living in private households in England. We provide a self-completion weight. This is positive for all the core members with a positive main interview weight who also completed the self-completion. And we also provide a nurse weight to analyse the data collected during the nurse visit. And this will be positive, again, for all core members with a positive main interview weight who also had a productive health visit. So briefly, I'd like to finish by giving some examples of using these weights in previous ELSA reporting, using examples from wave 10. So this table shows the prevalence of diagnosed health conditions by age and gender. The analytical sample is all core members who were productive at wave 10, living in private households in England. And as the information on health conditions is collected during the main interview, here we use the main interview cross-sectional weight to estimate the prevalence of diagnosed health conditions. This table shows the prevalence of health behaviours by age group and gender, again using wave 10 data. The analytical sample is the same as the previous table. All core members who were productive at wave 10, living in private households in England. Data on smoking and physical activity was collected during the main interview. So we used the main interview cross-sectional weight to estimate the prevalence of current smoking and physical inactivity. Information on alcohol consumption was collected during the self-completion. So to estimate the prevalence of daily alcohol consumption, here we used the wave 10 self-completion rate. And finally, this table shows the prevalence of diagnosed diabetes between waves 4 and 10 by age at wave 4 and by gender. The analytical sample is all core members who were productive at wave 10 and who took part in each wave between waves 4 and 10. So we used the longitudinal weight provided with the wave 10 data, which had the wave 4 sample at its base. So the variable named W10 wave 4 longitudinal weight, and applying that longitudinal weight for this particular set of core members at wave 10, we can see that the prevalence of diagnosed diabetes has doubled over the 15-year period from waves 4 to 10. So finally, I wrap up with some useful resources for those interested with further information. And thank you very much for listening.
Brilliant. Thank you very much, Sean. And then the last presentation for this part of today's launch is by Zoe on the right variables. So floor is yours.
Okay, so I'm Zoe Ilford from the Institute of Fiscal Studies. In this session, I'm going to give you a short overview of the derived variables that are available in ELSA. So these are a really useful resource for users because they pull together complex survey responses into a clean, harmonized set of variables that are ready for analysis. So today I'm going to cover three things. So firstly, what the derived variables are and why they exist. Types of information they contain, and I'm going to focus separately on the financial variables and the non-financial variables. And importantly, as this is only supposed to be an overview session and it's not going to be possible to cover everything, I'm going to talk briefly through the documentation that comes with the derived variables to show you where you can find more information. So the derived variables sit alongside the core questionnaire. When you download the ELSA data from the UK Data Service, in addition to the main files that contain all the core interview data, you'll also be given the financial and non-financial derived data as part of that download. So there's no need to download anything separately. So there's one data set for the financial and one data set for the non-financial variables for each wave. Both files have got one observation per ELSA respondent, so that means that they can be merged exactly on a one-to-one basis with the core data sets. So why do we do this? Well, ELSA is a complex multidisciplinary survey. It's particularly complex in the area of finances and economics because evidence suggests that you get better measures of income and wealth the more detail that you collect. So as a result, there are hundreds of questions on finances and economics regarding respondents' economic situation, and they're spread over several different modules. So we also allow respondents a lot of flexibility in the way that they answer the survey. So, for example, couples can report their finances jointly or separately, depending on how they actually organise their finances. They can report values weekly, monthly or annually, depending on what's easiest for them. They're also given the option to report a range of values for when they can't give us an exact amount. So all these factors together mean that the raw data is quite complex, and this is something that we recognise. The upside of this is that we do get good quality data that matches up well to other sources of data. So, for example, we've compared the economic data to the Family Resources Survey, and we find that it matches up pretty well. The downside is, of course, that it's difficult to bring all these pieces together, and it can make the data quite hard to use. So what we've done is we've combed through ELSA's many financial questions and we've transformed them firstly into uniform periods. So we chose weekly, we could have chosen any period, it doesn't really matter. We've imputed amounts where we have got incomplete or missing values, and that might be due to item non-response or cases where we have a bracket value rather than a point value. We've converted amounts so that they relate to a meaningful unit of observation, which for ELSA is either a couple or a single person. We've added together components into economically meaningful aggregates. So, for example, things like employment income, benefit income, and so on, so that you don't have to. And what we hope we end up with is something that's easier to use than the raw data. However, the problem is that there is a bit of a trade-off between making the data useful for your kind of average user who just wants to pick up the data and off they go with their analysis, and actually providing enough information for users who might want a little bit more detail. So even though we do all this work, we still end up with quite a lot of variables. So I'm just going to kind of take you through the sort of structure of the data and how it all works. So what's included in the financial derived variables? Well, it includes both top-level summary variables and more components. So for income, the most aggregate summary variable and the one that is useful to a wide range of users is simply total income. Then we break that down into more disaggregate components. So the components like employment income, private pension income, state benefit income, and these correspond broadly to components of income that are used by the Department for Work and Pensions in their inequality statistics, for example. So these measures are then broken down even further. So, for example, state benefit income can be split into its the individual benefits that people might receive. Employment income can be split into the main job and second job components. On the wealth side, the most aggregate top-level summary measures is total non-pension wealth. As an aside, we do also measure pension wealth, but these are created separately and on a more ad hoc basis. Currently, we've got pension wealth available up to Wave 5. So total non-pension wealth is further divided into primary housing wealth. That's basically the value of your main home, and also non-primary housing wealth. Non-housing wealth. And that's in turn made up of savings and investments and physical wealth. So physical wealth is things like second homes, business wealth, land, and that kind of thing. Primary housing wealth is made up of gross housing wealth. So that's basically just the entire value of your home. And we separately measure any mortgage debt that you might have on that house. And if you net that off, you end up with net primary housing wealth. But you can look at those two components separately if you want to. Finally, we also have measures of financial debt, and that includes things like loans, credit cards, but also informal loans from private individuals. We also separately include measures of quintiles of wealth and income. So what these do is they rank people according to their income or wealth, and then we divide them into 5 equal groups. And those can be a useful summary measure to use in your analysis. Just a few key points to remember when you're using the data. So all income flows are measured weekly. Doesn't matter how the underlying variable has been collected over what time period, and that ensures that all different measures are comparable. The unit of observation is the individual. This means that there is one observation for each individual in the data. However, income and wealth variables, as we've measured them in these derived files, relate to the benefit unit. So you can think of a benefit unit as a family consisting of a couple or a single person, along with any dependent children that they might have. So where we have a couple, we sum income and wealth across that couple. And the measure of wealth can be thought of as the amount of income or wealth that that couple or single person actually has access to. But it does mean that the measures are not strictly comparable across couples and singles unless you do something called equivalization. So equivalization is something that adjusts for these differing sizes of benefit units, and you will find both equivalized and unequivalized measures of income in the data. However, we don't equivalize wealth data. It's not really clear from an economic perspective how you equivalize wealth, given that it's a stock designed to be drawn down over a period of time. So that's a sort of quick overview of the financial variables. So we also provide a wide range of non-financial variables. The purpose of these is to centralise complex derivations. So instead of redoing work that's been performed by both the ELSA team and other researchers, you can rely on consistent quality checked measures. Whenever you use the ELSA data and start to think about what variables you might need, it's always worth familiarising yourself with the non-financial derived variables and checking to see whether what you want to create, check to see whether it already exists to save you having to derive it yourself. So the variables include a number of identifiers that aren't available in the main data. That includes things like an identifier for a couple, tracking whether that couple remains a couple over time. Contains lots of information about children variables, which are quite complex, family type, labour market activity, pension summary variables, health summary, expectations and expenditure. They also include variables that take into account that for longitudinal data, not all questions are asked in every wave. So if we've already got information from a previous wave, we don't re-ask it. So just to give you a few examples, one of the most frequently asked for variables is the variables relating to children. So in ELSA, the respondent can have children both in and outside the household, and they can have inside the household, they can have dependent children or non-dependent children. So, and these different types of children, the information on these different types of children is collected at different points in the survey. So we combine all this information from the different sections, and we create some variables which give you information on all the children together. And for each child of each respondent, it will give you the type of child, so whether they're natural, adopted or stepchild, whether the status of that child, whether they're living in the household, outside the household, whether they're dependent or non-dependent, and obviously their age and their sex as well. We also give sort of higher level summary child variables, so basically the number of children in the household or the benefit unit in these different age bands. And similarly for grandchildren, we collect information on grandchildren both in and outside the household, and that can be quite complex to gather together different bits of information, so we provide these summary variables. Family types, another useful one. It's a 14-category classification describing the type of family, so whether they're single, couple, extended, with or without children, multiple benefit unit, that kind of thing. These next two variables are examples of information where we don't collect it every wave, or else we just update it. So what we do here is we consolidate all the information from all the previous waves into a clear measure that's valid for everybody. Private pension variables, as I said before, we don't have pension wealth past wave 5 at the moment, and the pension information in ELSA is like all the rest of the financial information, it's quite complicated. But these variables that we've created, so whether you're a member or not of a private pension scheme, whether you're currently contributing to one, and the number of years you've contributed to a pension scheme, can all be used as useful proxies for pension wealth. So they're worth a look at if you are interested in that. So that was a quick overview of what's available. Just going to take you through the documentation now. You can find extensive documentation on these variables. It covers how the variables were imputed, how the variables were derived, and how the naming conventions that we use. So, and there's also more detail on the way that the data are collected. So, for example, unfolding brackets and the unit of data collection, and some frequently asked questions. So if you're unsure how a variable is derived, documentation should always be your first stop. These two files, so these documentation files you get obviously with the main download. These give you just a basic overview of the two different types of data, the financial and non-financial derived variables. These two are more detailed spreadsheets, and they give you much more detailed information on how each variable was derived. And finally, we have a more in-depth description of the imputation methods that are used to derive the missing and incomplete financial derived variables. So this is worth a read if you care about how this was done, and maybe you might want to do it differently yourself. But for the average user, it's probably not an essential read. What's more important is these two Excel spreadsheets. So these two do contain quite a lot of information on how each variable was derived. So before emailing us to ask for information, it's always worth checking these documents, as your answer may be found in here. That being said, of course, you're welcome to email us on the elsa@ucl.ac.uk email address, and we'll be happy to answer any questions that aren't asked in the documentation, or whether you want any additional information. Thank you, and I think I'm handing back to Giorgio now.
Thanks so much, and thanks to all presenters. We're now going to open up the Q&A session. Before doing that, I just want to quickly share some slides. Because I think some users have actually asked us questions before joining today's launch, and hopefully we have answered some of these questions already through the presentations. But I would like to go through some questions that we haven't touched upon yet. And I would also like to remind anyone who wants to apply for a grant that will require the use of ELSA to actually get in touch with us if you think that you will need special license or secure access data, so that we can kind of work together and make sure that your applications is not going to be rejected, and you will be able to actually do the work that you promise in your grant application. So if you want to use ELSA and datasets that are not the end of user license datasets, please maybe drop us an email, and we will make sure that your application and the intended use of the data can proceed without any issues and very smoothly. Having said so, I will just answer some kind of brief questions that have been asked before, and one of them has also been asked in the chat today. So hopefully I can give you some updates on mortality as well. But first of all, some have asked about medical prescription and drug coding and drug use. So just to remind you that we do have some basic information that is available in the nurse visits and the nurse end of user license datasets for wave 6 and for wave 8. However, if you want to have a detailed list of all the drugs and all the typology of drugs that respondents use, you actually need to apply for a special license data set, and that will apply for nurse visits from wave 8 onwards. And if you want to know exactly what kind of drugs are available and prescriptions are available, there is a manual that you can consult, and this is called the Coding Prescribed Medications, where you will find all the information. And this has been I think, mentioned before and throughout the various presentations. We really try our best to keep all our guidelines and all our documentations up to date, and we always release new and updated guidelines and user guidelines at each new data release. So, make sure that you actually consult all of these, and they can be found on both the ELSA and the UKDS websites, and where we have extensive study documentation that covers all of the waves and all of the sub-studies as well, nurse visits, end of lives, questionnaires, technical reports, and so forth. So please, make sure that you also use the available information that we provide on our website. Another question that I think has popped up on today's Q&A as well is about mortality. So we are working towards making mortality available to all users, and we are planning on doing so via 2 different routes. So the UK longitudinal linkage collaboration will actually have, for those who have given consent, links to their official mortality records. And this means that you will also be able to have access to both the cause as well as the precise date of death for those respondents who have died and who had given consent to have their data linked through the NHS. However, this application, is still a little bit work in progress. So we are hoping that in the next few, from January onwards, you're going to be able, you can start applying and also get data and all of the end of user license data sets through the UK LLC. So you're more than welcome to start applying and to start also reading all the requirements that are needed to actually access the UK LLC data. Because, for instance, you have to be an ONS accredited researcher, which means that you have to take a test and also a course through the ONS. And at the moment, the UK LLC data can only be accessed from the UK. So only researchers based in the UK will be able to access this detailed level of information about mortality. And we are working to make sure that this can be expanded, but we don't see this happening anytime soon. Some of you might also remember that at some point we had the index file that would give an indication of whether respondents had died and also roughly when they died. So, kind of during which field work people had died. And this was usually communicated by relatives or information obtained by the interviewers during field work. So we are now working on updating this index file and making it available by the end of 2026. But we are still also deciding what level of information is going to be available. But we are aware of the interest that researchers have on mortality, and we're making progress and our best to ensure that as many researchers will be able to have and access information about mortality. Having said that, I think there was one question that I'm going to ask Sean to answer. But before I give him the floor, I also want to remind you once again that if you have any questions or specific information or details that you want from us, you are more than welcome to send us an email via the generic elsa@ucl.ac.uk email address. And I think I will now stop sharing and see if there are more questions that we can answer. I also want to mention that if any one of you wants to unmute themselves and ask the question live, just raise your hands and we can actually unmute you and allow you to speak. Sean, would you like to answer the question that was asked? Maybe read it loud and answer the question if you can. Thank you.
Okay, so you want me to read the question. So the question was, how is the bias due to refreshment samples dealt with in the weights? And so I'm thinking about this. I'm going to try and be ambitious and try to answer this with reference to cohort 10. So the refreshment sample with cohort 10 was taken from the Health Survey for England from 2016, 17, 18 and 19. And then obviously their first opportunity to participate in ELSA was at wave 10. And so how do we deal with the bias due to the inclusion of cohort 10? So first of all, I guess let's think of the cohort 10 as the group in itself. So the way cohort 10 was sampled was that we oversampled non-white minority ethnic groups because only non-white ethnic groups were taken from the 2019 Health Survey for England. So cohort 10, the sample for cohort 10 was oversampled in relation to ethnicity. So one of the first steps we had to do was to create a selection weight to adjust for the oversampling of minority ethnic groups. And basically what that is doing is adjusting the ethnic distribution of the sampled cohort 10 members to move from what it was to what it looked like in 2016 to 18, when there was no oversampling of minority ethnic groups. So essentially we created a selection weight which corrected for the oversampling of the non-white ethnic groups, which mainly occurred because in 2019 we only selected persons from the Health Survey who were non-white. So there was a selection component and a selection bias that we dealt with through selection weighting. But then we have non-response bias. So first of all, we have non-response bias to the Health Survey for England itself. So there'll be biases in who takes part in the Health Survey for England. So to deal with that, we take forward their non-response weight from the Health Survey. So we hope that kind of deals with the non-response to the initial survey, which was the Health Survey for England. But then we also have a non-response component from HSE to ELSA, and we model non-response using predictors with variables that were collected at the Health Survey for England. So we have a selection weight, we have a HSE non-response weight, and then we have an additional non-response weight to model potential bias from the Health Survey for England to ELSA. So putting all those weights together, we hope then we have a cohort 10 that is representative in terms of ethnicity and is also suitably non-response weighted. But then we have to combine cohort 10 with the other ELSA cohorts. And when we do that, then we find we have more of a ethnic distribution because we've added the cohort 10, particularly the older part of cohort 10, the over 65s, which only included minority ethnic group members. So once we put cohort 10 together with the other ELSA cohorts, we have to make an ethnic adjustment so that participants from the minority ethnic groups are slightly downweighted, so that then the ethnic distribution among the ELSA sample as a whole reflects the ethnic distribution that we think is representative of the population aged 50 and over. So it's very complex adjustment, and we explain that in the technical reports. And then in the final stage, we have the calibration weighting. So after selection weighting and non-response weighting, again, our weighted sample may differ from the target population along variables such as age, sex, tenure, marital status. And the final step of the calibration, again, as I mentioned, tries to align the weighted sample to perfectly align with the distributions of your target population. And crucially, as part of that calibration, we are making sure that the age profile of the ELSA sample matches the English population amongst the 50 years and over. What's particularly important is that, so we're asking particularly the younger members of the refreshment samples, so those aged 50, 51, 52, 53, and 54, we're asking them, those participants of that age in the ELSA data, to represent the English population of 50 to 54-year-olds. So you'll find that that group in particular has higher weights on average, again, to ensure representativeness in relation to the 50-plus population as a whole. So to summarize, there's a lot going on. There's selection, non-response, and calibration, and all that involves different groups of ELSA cohorts. So there are lots of different pieces to the jigsaw that we end up putting together.
Thank you so much, Sean, and I hope it answers the question. It's a very complex business, the weighting one. We also have another question from someone asking about epigenetic data, and I wonder if, Andrew, you could answer and take that question. Thank you.
Thank you, Giorgio. Yes, I'm very happy to answer. The question is whether we have epigenetic data and whether it will be made available. The answer is that we don't currently have epigenetic data. We have genetic data, but the epigenetic assays are an additional step that we don't currently have the funding for. Our hope is to have to introduce those, along with further genome-wide assessments as well, because the genetic data from ELSA only was carried out on blood samples in 2004 and 2008. So we've got new people who come into ELSA who we don't have any genetic data for. So I think it's important to have that. I would just like to point out one other aspect of the biomarker data that Paula mentioned in passing, but I think is potentially interesting, which is another wave of assessment of various hormones from hair. The reason why we use hair is that hormones are secreted quite slowly into hair, so the values you obtain from hair samples represent the last 2 months of activity rather than the very short-term effects that you can get with other sources. We carried out analyses of hair in wave 6 in 2012, and now we've carried out another set of hair analyses for wave 11. It's around 2,800 people have usable data. So we have data on cortisol, cortisone, progesterone, testosterone, but we've also added a new set of data, which are the endocannabinoids. Those of you who might be familiar with this area, this is quite a new area of work on neurotransmitters, and I think this will be quite interesting to look at in the future. These data we're just trying to prepare at the moment, so they haven't yet been deposited, but I hope we'll be able to deposit it quite soon. Thank you.
English Longitudinal Study of Aging, ELSA. Thank you for watching.